Hello, in this video I will do an IBEW introductory test regarding literal equations. So this will be part of this section will be a little bit part of the exam, so let's begin. Okay, so uh, when they say literal, they literally mean different letters, and you just gotta isolate a certain letter, right? So in the other ones, you're used to only seeing one letter like X, A, or B. But this one, we have different letters and we got to isolate a letter, right? So in question one, we have C equals 5A plus B, and we must find A. As you can see, they don't give you any values. They just want you to isolate. That's it. Okay, so what I would do is, in order to solve here, let me write it out here. C equals 5A plus B. And you want to solve for big A, right? So first, what I'm going to do is um, I'm going to get rid of that B by subtracting B from both sides, right? So I get C minus B equals to 5A. Then what I would do is isolate A by getting rid of this 5. Now I'm not going to subtract 5. I can't do that. I'm not going to subtract 5A. This is so all you got to do is think of the opposite. Since this is squished, this is multiplication. It's like saying 5 times A. You do the opposite of multiplication. You're going to divide only by 5 because you only want to get rid of the 5, right? So when I divide both sides by 5, I get A. So this actually does not become 0. This actually becomes 1, and then you have this A. So what's 1 times A? A. And then on the left, you're left with C minus B over 5. Okay, so which one is that going to be? Letter D, C minus B all over 5. Okay, now that one wasn't too bad. Okay, let's move on to question two. Isolate the variable from the formula. S equals A plus, parentheses, A plus B plus C all over 2. We want to solve for small c. And I believe they're all lowercase. So let me write it out here. We have S equals, so I don't like this slanted line. I like it completely horizontal. So that's what I'm going to do. I'm going to rewrite it as a horizontal, that slanted line or that divided by 2. Let's make it a completely horizontal line. Over 2. Okay. And then what I will do is get rid of the fraction or get rid of this 2 by, I can cross multiply or I can multiply both sides by the LCD. This time I'm just going to multiply both sides by the LCD. So my LCD is 2 because you have a 1 and a 2. They're different bases and they're most primest form, so you just bring them together. So your LCD is 2, so you're going to multiply both sides by 2. So 2 times S is 2S. And then over here, 2 times 2, these 2's cancels. So you're left with A plus B plus C. You don't have to put the parentheses anymore. You can get rid of that. It could disappear. So now all we got to do is isolate C. So what you could do is you could do two things at a time. You can get rid of this A and you can get rid of this B all at once. You don't have to do it one at a time. By for this A to get rid of this A, this is addition. So you're going to subtract A. And then to get rid of this B, this is addition. So the opposite of addition is subtraction. Okay, so this cancels. So now you're left with C on the right. And then you have on the left, you have 2S minus A minus B. Note, you can't combine these at all, right? Why? Because they're different letters. So yeah, you could don't be confused. You may see the C on the right. Why? That's the same thing as C. You can rewrite that as C equals 2S minus AB because some kind of property, I think it's the commutative property. right? So you can, this doesn't change the problem. So my answer will be 2s minus a minus b. Letter A, right? 2s minus a minus b. Correct. Okay, move on. Let's solve for small d. So let me rewrite this if it makes it easier. So this, I don't like that slanted line. I'm going to rewrite it as a completely horizontal line. So you have big F times small d all over t, small t. So we want to solve for small d. Um, what I could do is I could cross multiply or get rid of the fraction. It's up to you. There's only two sides. You can cross multiply because there's only two sides. So if you decide to cross multiply, this would be p times t, or big P times small t equals to 1 times FD. That would be F and then lowercase d, right? So now you got to solve for lowercase d. So all you got to do is get rid of this big F by dividing both sides by big F. So you get small d equals to big P t all over F. Okay, so letter D. Isolate the variable from the formula a equals x plus 5y. Solve for small y. So all you got to do is, so you have, let me rewrite this. You have a equals x plus 5y. So all you got to do to solve for this is you got to get rid of this x. So I'm going to subtract x from both sides. So you get a minus x, oops, big A minus x equals to 5y. And then to solve for y, you just got to get rid of this 5. And to do so, because this is multiplication, do the opposite. You're going to divide both sides by 5. So you get y equals, so this cancels, so you're left with y equals. Notice I could put the y on the left or right, it doesn't change the answer. And then you could put this on the right, a minus x over 5. So which one will that be? Okay, so don't be, is it a minus x over 5, or is it b, a over 5 minus x? It is not b, and it's not c, and it's not d. Why isn't it b? Because this is all over, this horizontal line is all over. So it has to have include. So if it was like a over x minus x over 5, that's the same thing as this, right? So this is the correct answer. Okay, so that's an easy mistake. Okay, question 2. Isolate the variable from the formula. Big M equals 2n minus 7p, so we got to solve for big N. So let me rewrite this. M equals 2n minus 7p. Solve for n. So first, what I'm going to do is get rid of this negative 7p by adding 7p to both sides. So you get m plus 7p equals to 2n. And then I'm going to do is solve for n by getting rid of this 2 by dividing both sides by 2. So you get n equals m plus 7p all over 2. Yep, letter C. Okay, move on to question 7. Okay, so now this is a little bit trickier. Solve for k. So we have h equals 12 plus 3 times k, 3 parentheses k minus 1. I know what you're thinking. Maybe we should just get rid of this 3. Let's see. Here, let me rewrite it. I know what you're thinking. We should just get rid of this 3. Um, I don't think I want to do that yet because we're dealing with fractions and I don't want to do dealing with fractions. So let's just FOIL out this 3. Let's see what we get. I don't know if this is going to be easier because I haven't done this exam. So, I mean, I haven't done this particular exam. So let's see. 3 times k is 3k. 3 times -1 is -3. And then you have h equals 12, right? Then what you want to do is you want to solve for k, but remember what we said when we were doing first one step and two step equation. Always check if you can combine like terms on the right side and on the left side. So on the right side we have 12 minus 12, and this is a positive 12 plus 3k minus 3. Is there anything we can combine? Yes, we can. We can combine the constant 12 minus 12 and -3. So we get 3k because that stays the same. But what is 12 minus 3? It is 4, 5, 6, 7, 8, 9. Okay. Now go ahead and solve for k. So now what I'm going to do is subtract 9. Subtract 9. So you get h minus 9 equals to 3k. And then you solve for k by getting rid of this 3 by dividing everything by 3. So you get k equals h minus 9 all over 3. Wait, I don't see our answer. Because um you don't see our answers because they kind of simplified it a bit more. You see this horizontal line? It's all over 3. So what that means is you're dividing h by 3 and that -3 by 3. So this is equivalent to saying h over 3 and then -9 over 3. And when you simplify that, h over 3 just becomes h over 3, -9 over 3. -9 divided by 3 is -3. So that concludes our answer is B. Okay, question 7, solve for small b. We have a equals 1/2 times small b times small h. So I could put a little dot to represent multiplication. I don't have to put it all squished. So what would I do first to solve for small b? First, I would get rid of the fraction by multiplying both sides by the LCD, which is 2. Okay, so I'm going to multiply both sides by 2. So this side 2 times a is 2a. This side 1/2 times 2, the 2's cancel, so you're left with b times h. And then a small solve for small b, so you got to get rid of this h by dividing both sides by h. So this cancels, so you're left with b equals 2a all over h. And what would that be? Oh, letter A, 2a over h. Next one. Question 8, we have 3z minus 4x plus 12 equals 12 minus 19 minus 2x, and we got to solve for z. Okay, so here's the left side, and here's the right. So when we're dealing with one or two-step equation, we always got to check if we can combine like terms on the left and right before we move things around. So look at the left side. We have 3z minus 4x plus 12. Can we combine like terms? No, we can't. Because they're different letters, right? We have a Z, an X, and then a constant. They don't mix. And then on the right, can we combine them? No. Constant and a letter X don't mix. So next, what you have to do is get all the variables on one side. So our goal is to solve for Z. So um locate where Z is. Z is right here. Let's just move everything to the right. So get rid of this negative 4x, get rid of this 12. So let's start with negative 4x. How do I get rid of it? By adding 4x to both sides. Okay, so you have, and then just get rid of this 12 by subtracting 12. Okay, so you have 3z, and then you can combine the 19 and negative 12. What is 19 and negative 12? 7. And then what is negative 2x plus 4x? Positive 2x. And then you solve for z by dividing everything by 3. Yeah, as you look at our choices, it's not all of, they just individually divide everything by 3. So this cancels. You're left with z equals to 7/3 plus 2/3 x. Okay, so that looks like it's letter B. Okay, let's start with, let's do 9. Isolate the variable from the formula. We have x, y plus z equals 7 plus x. Um, let's solve for x. So first, here, let's look on the left side. Here's the left, here's the right. Can we combine like terms? X, y plus z? No, different letters, right? No. It's a constant and a letter, no. So our goal is to solve for x. So what I would do is probably subtract this z, because look where x is right here. So I'm going to subtract z from both sides. Oh, look, this comes out nicely. And then this z's cancels. So now you're left with xy on the left. And then on the right, you're left with 7. Um, Solve for x, so you got to get rid of this y. This is multiplication, so the opposite of multiplication is divide. So you're going to divide both sides by y. So this cancels or becomes 1. So you're left with x equals 7 over y. And that is letter D. Question 10, isolate the variables from the formula. We got to solve for small r. So, okay, this looks bad. This can be a difficult one, especially when you have a time limit. So you have x equals 9 plus r minus 1 square over 81. And our goal is to solve for small r. So what would I do? I would get rid of the fraction. We have a denominator of 81. This 9 has an invisible 1. This x has an invisible 1. And there are different bases, so put it all together. So my LCD is 1 and 81, which is 81. So that is our LCD, so we're going to multiply everything by 81. let's see what help if this makes it better. What's 81 times x? 81x. What's 81 times 9? That is, oh, so I know that 81 times 9 is 9. 9 times 8 is 9 times 8 is 72. And then 81 here cancels. So you're just left with r minus 1 square. Okay, so go now. Our goal is to solve for r. So next I would subtract 729. So you have 81x minus 729 equals to r plus r minus 1 square. And then you're going to solve for r. So you're going to get rid of this power 2 by taking the square root of both sides. Then you get, so the happen here is the power 2 disappears, so you're left with r minus 1. And then over here, you're left with 81x minus 729. Okay, as you can see, you don't see our answers yet. And then what I would do next is get rid of this negative 1 by adding 1 to both sides. So you get r equals square root of 81x minus 729 plus 1. The plus 1 is not inside the radical, right? So you can eliminate a few. You can eliminate the first one, the third one, C, because they don't have a plus 1. But why don't you say our answer? Because they simplified it a bit more. Um, the square root of 81x, well, I know the square root. Oh, I know what you could do. Inside the square root, 81x minus 729, can you factor out a common denominator? I think so. I think they're both divisible by 81. So that is a tricky one. So yeah, it looks like they're all divisible by 81. So what you'll do is factor out an 81 or this part. So you're going to factor out, hold on. So it's going to be like this square root, and then you're going to factor out an 81. So this is going to be, so this 81 is still inside the square root because you're just factoring out an 81. So this is going to be square root 81x. And then what do you multiply 81 to get negative 729? Uh, I think 9. And then there's a minus, so it's negative 9. Okay. So why don't you see our answer? Because you can simplify the square root of 81. So the 81 is inside the square root. So what's the square root of 81? It's a perfect square. It's 9 because 9 times 9 is 81. So this 81 becomes a 9. And then inside you're just left with square root of x minus 9. And then you have that plus 1. So which one is that going to be? Letter B. So yeah, that one's a tricky one. I'm not gonna lie. Okay, so it looks like they're getting harder as I get more. So question 11, isolate the variable from the formula. A equals 2 minus 1 over square root of b minus 3. You got to solve for b. Okay, so a equals 2 minus 1 over square root of b plus 3. So what I would do is, there's a lot of things you could do. You could get rid of the fraction. Okay, you don't, okay, you could get rid of the fraction by multiplying both sides by the square root of b plus 3, but there's another thing you can do. You see this minus 1 over square root of b plus 3? What if I add both sides by 1 over square root of b plus 3? Okay, so what happens is when you add this cancels, so you're left with 1 over square root of b plus 3 plus a equals to 2. Okay, then what I would do is so get rid of this a because I want to solve for b by subtracting a. So you have 1 over square root of b plus 3 equals to 2 minus a. Then what I want to do is oh, it's just a tricky one. Then what I want to do is solve for b. So what could I do? If you look at all the choices, they have a square in the bottom. So maybe there's a big clue that I should get rid of this radical by squaring both sides. So I'm going to square both sides. Let's see what happens. Square here and square there. So this one's a, so what they really mean is you're squaring this entire fraction by squared. So what's one square? 1. What about the bottom? What's the square of the square root of b plus 3? Well, the square root disappears. You're just left with b plus 3. That's good because you want that radical gone. And then on the right, be careful. This is the same. You're squaring this entire thing. So it's really 2 minus a squared. Okay, almost there. So your goal is to solve for b. So now you can cross multiply. So this has a denominator 1. So 1 times 1 is 1. And then on the right, it's uh parentheses b plus 3 times 2 minus a squared. So your goal is to solve for b. Do not FOIL this out. Do not FOIL it out. What instead, get rid of this parentheses 2 minus a squared by dividing both sides by 2 minus a squared. So this cancels. So you're left with, on the left, you're left with 1 over parentheses 2 minus a squared equals to b plus 3. But almost there. All I got to do is get rid of this 3 by subtracting 3. So I get 1 over 2 minus a squared minus 3 equals to b. There we go. That's my final answer. So which one will that be? Okay, you don't see our answer because it looks like it could be D, but the thing is, it's not D. On the bottom, we have positive 2 and negative 8. Over here, this is a negative 2 and a positive 8. So there's a good chance they factor out a minus. So if you factor, so on the bottom right here, they factor out a minus. So if you factor out a minus, it's going to be negative 2 and positive a parentheses squared. And then what they did is they could put that minus, you could put that negative either on the bottom or in the center or even on the top. So that looks like our final answer shall be A. Because what happens is I factor out this minus on the bottom, and now I have a positive A and a negative 2, and then that minus can be on the top, and then this negative 3 stays the same. So it looks like it's B. Yeah, let's see. Let's see if that's correct. Incorrect. The correct answer is D. Uh, okay, let me do this problem again because I don't understand why I thought it was B. Yeah, let me do this one again. So maybe I'll try a different approach. Maybe I should get rid of the denominator. Maybe that's what I should have done. So do a different approach. Let's get rid of the denominator. So this 2 has a bottom 1, this a has a bottom 1, this down here has a bottom of square root of b plus 3. So it looks like my lowest common LCD is 1, 1, and then square root of b plus 3. So it's really just square root of b plus 3. Okay, so what you're going to do is multiply all sides by the square root of b plus 3. Okay, everything. So on this side, a times square root of b plus 3 is just a square root of b plus 3. Over here, 2 times this, that's just 2 square root of b plus 3. Over here, there's a minus, and then these are the same, so they cancel, so you're just left with -1. Okay, that don't know if that helps, but now our goal is to solve for b. Um, let's, you see how we have both a square root of b plus 3 here and a square root of b3 over there? What you want to do is, that's good. What you want to do is get all the square root of b plus 3 on one side so you can factor that out. So let's move this 2 square root of b plus 3 on the right, left by subtracting 2 square root of b plus 3 to the left as well. So this cancels, you're left with -1, and then you're left with a square root of b plus 3. Okay, so on the left side, as you can see, they both have a square root of b plus 3, so that's good. So all you got to do is factor out a b plus 3. And then we have this a, so bring down an a. And then you have this -2, so bring that -2 equals to -1. Okay, almost there. You want to solve for b, so next step is do not square both sides. Let's get rid of this a minus 2 by dividing both sides by a minus 2. Okay, so now on the left side, you're left with square root of b plus 3 equals to -1 over a minus 2. Okay, then what you want to do is get rid of this radical by squaring both sides. Square here, square there. So what happens is this radical disappears. You're left with b plus 3. And then on the right, it's, be careful, it's really -1 squared over a minus 2 squared. So you're squaring the numerator and the denominator. I see what happens. So what happens is what's -1 squared, it becomes +1. And then on the bottom, what's a minus 2 squared, it just becomes a minus 2 squared. Okay. Last step, solve for b. So you're going to subtract 3 from both sides. So this cancels. So you're left with b equals 1 over a minus 2 squared minus 3. So that's why it is letter D, not B. Okay, so my mistake was I should have just got rid of the denominator by multiplying all sides by the LCD. Okay. Question 12. We have K equals 1/2 2 times YV squared. Okay, so it looks a bit confusing. We got to solve for small v. So I'm going to rewrite this as K equals 1. And then this slanted line is the same thing as horizontal 2. And then it's times, so that means that times means it's still on the bottom. It's not going to be on the top. It's going to be on the bottom, and it's going to be YV squared. Okay? So your goal is to solve for small v. So what I would do is like cross multiply. So 1 times 1 is 1, and then it's 2, and then 2 times this whole thing. So it's 2 times k times y times v squared. Okay, so your goal is to solve for v. So now what I would do is um this whole thing right here to see how this is all squished. Um you can rewrite it as 2k, you don't need that parentheses, 2k y v squared. I think that would be much easier. So now what you could do is next is get rid of this 2ky by dividing both sides by 2ky. This cancels. So you're left with v squared, and then it's 1 over 2ky. And then solve for b. So you're going to solve for b getting rid of this power too by taking the square root of both sides. So v equals square root 1 over 2ky. Why don't I see my answer? Mm, I think they simplified this. I know what they did. So did you know this thing, square root of this whole thing is the same thing as square root of 1 over square root of 2ky. And then the square root of 1 is the same thing as 1. So it's 1 over square root of 2ky. And I think what they did was they got rid of this. They got rid of they rationalized the denominator by multiplying both sides by square root of 2ky. Okay. So what happens is on the top, what's 1 times square root of 2ky? It is square root of 2ky. And then on the bottom, what happens when you multiply the square root of the same thing, square root of 2ky times square root of 2ky? The radical disappears, you're just left with 2ky. And I don't see my answer yet. Oh, I know. Jeez, I made a mistake. You see this times, I was wrong. That time should be on the top. So I wrote it wrong. So it's really k equals 1 over 2. And then this is multiplication. So that means it should be on the top, not on the bottom. If it was another slanted line, it would be on the bottom. Okay, so that's the mistake I made. So yeah, it's getting harder as we go on. So this times yv squared should be on the top. So it's going to be yv squared. So you have k equals yv squared over 2. Let's see if we get an answer here. So our goal is to solve for v. So what I would do next is go ahead and cross multiply. So 2 times k is 2k. 1 times that, it's yv squared. And then solve for v. So you're going to get rid of this y by dividing both sides by y. So you have 2k over y equals to v squared. And then solve for v by taking the square root of both sides. Okay, there I go. V equals square root of 2k over y. Okay, so yeah, that's the mistake I want. So see, so this multiplication means it's going to be on the top. If it was a slanted line, you'll put that yv square on the bottom, but it's not. 2k. Yep. Let's see if the correct answer is C. Correct. Good. Okay, let's move on. 13. Isolate the variable from the formula. We have c squared equals a squared plus b squared, and we got to solve for just b, regular b. So you have c squared equals a squared plus b squared, and you want to solve for big B. So what I would do is subtract a squared from both sides, subtract a squared from both sides. So you get c squared minus a squared equals b squared. Then what I would do is solve for b by taking the square root of both sides. So you get b equals the square root of c squared minus a squared. And I know what you're thinking. Why don't we just take the square root of c squared? We can't do that because there's a minus. Yeah, we can't. Can we factor anything between the c and the a? No. So this is my final answer. So that would be, I think, letter C. Wait, what is D? No, D is wrong because our A is positive. I mean, our A is negative, not positive. So it has to be C. Um, Isolate the variable. So we got to solve for small r. So we have V equals P pi r squared times h. And we got to solve for small r. So what I would have to do is get rid of this pi first and get rid of this h in one step, which is easy. You just divide both sides by pi h, right? So the pi cancels, the h cancels. So we're left with r squared equals v over pi h. Solve for r, so you take the square root of both sides. So you get r equals the square root of v over pi h. It would be letter A. So it's, yeah, you can't really, it's square root v and then the slanted line pi, and then this multiplication h. Yes. Let's see if that's correct. Correct. Okay. Okay. We have P equals PATM plus, I think that's a P. No, I think I think this is a sigma. This is not a P. This letter right here is not a P. It's a sigma. And then you have, yeah, so what you want to do is isolate that sigma. So yeah, this is not a P. It looks like a P, but it's not. So first what I would do is I here, let me write it out. P equals P and then ATM plus sigma. I don't know. It's GH. So we gotta solve for this. So first I would subtract P ATM. So you get P minus P ATM equals to sigma. So sigma GH. Then what I would do is get rid of this G and this H by dividing both sides by GH. So this cancels. So you're left with sigma. So which one will that be? That would be this one, the D, right? P minus P ATM all over GH. Correct. Mhm. Let's move on to question 16. We gotta find big F. Okay, this one's a little bit more difficult. Yeah, so just two more. Okay. So this is where you kind of need to know, you want to get rid of the fraction by multiplying all sides by LCD. So you have AB or G equals XY. So what I would do is, these are capital. I would get rid of the fraction by multiplying both all three sides by the LCD. You cannot cross multiply because there's more than two sides, right? So if you look at the bottom, we have a G, an F, and a 1. They're all different bases and they can't be broken down. So if you have different bases and they're in the most primes form, just bring it all down together. So it's G times F times 1, which is really just GF, right? So you're going to multiply all sides by GF. Okay. So what's GF times AB over G? The G's are the same, so they cancel. So you're left with F AB plus over here, what happens when you multiply GF by CD over F? Well, I notice that the F are the same on the top and bottom, so they cancel, or just kind of visually do it in your head. So you're left with G, C, D, right? Right? The F's cancel, so you're left with G, C, D. And then on the right, what's GF times XY? Nothing cancels, so you're just left with GF XY, right? So our goal is to solve for F. So what I would do is, because this is one big mess, check if you have any other F's, like a repeat of F anywhere. No, we don't. So F is right here. So what I would do is get rid of this whole thing. So I'm going to subtract G, C, D from both sides. You have F, A, B equals to G, F, X, Y minus G, C, D. Okay, then I want to solve for F, so I'm going to get rid of this AB by dividing both sides by AB. Okay. Okay, so it looks really strange. Okay, so we have G F X Y minus G C D all over AB. I don't know if we have our, let me check for answer D. I think what they, yeah, what is our, I don't see our answer. It would be, which one of these could be, if I divide everything by AB, uh, yeah, I multiply everything by GF, so this G cancels, so you're left with FAB, and then F cancels, so you're left with GCD equals to GFXY. And oh, I see what I made mistake. There is two F's. There's an F right here, so I shouldn't have done that. I shouldn't have moved things around. So you know how I said check if you have a repeat of F? There, I there is. There's an F right here. So what you want to do is get all the F's on one side. So do not move this GCD first, GCD yet. Instead, you see there's an F, an extra F right here. So, and then you have an F here. So what you want to do is get all the F's on one side. So you can't just subtract F. You got to subtract this whole G, F, X, Y. G, F, X, Y. And then because this GCD does not have an F, get that on the other side. So you're going to subtract GCD. Subtract, oh, look, GCD. There's two GCDs. So now on the left side, you're left with FAB minus GFXY. And then this cancels. But over here, you have a GCD minus GCD. Isn't that the same thing as negative 2 GCD? Uh, yeah, and then over here, let's see what happens. And then over here, on the left side, see how they both have an F? That's what you want to do because you can factor out an F. So this is going to be F AB minus GXY equals negative 2 GCF. And then you want to do is get rid of this AB gxy by dividing both sides by gxy. You see our answer now? On the bottom, AB minus gxy, is there anything you can take out? No. Um, Let me start from the beginning. These ones are, yeah, this one's a difficult one. So you have AB over G plus CD over F equals XY over 1. So what I'm going to do is still get rid of the fraction by multiplying all sides by the LC. So if you look at the bottom, we have a G, we have an F, and we have a 1. They're different bases in the most primitive form, so just bring it all together. G times F times 1. Really, it's just GF. Okay, so you're going to multiply all three sides by GF. Okay, so let's do here. What's GF times AB over G? The G's cancels, right? So you're left with FAB plus, over here, what's GF times CD over F? The F's cancels, so you're left with GCD. And then over here, GF times XY, nothing cancels, so you're just left with GFXY. Okay. Our goal is to solve for big F, so do we see an F anywhere? Yes, I see an F here, and I see an F there. Okay, I what you want to do is, yeah, okay, now I see my mistake. What you want to do is get all the F's on one side and anything that doesn't have an F, move it on the other side. So I'm going to move this GFXY on the left by subtracting GFXY. And then this GCD doesn't have an F, so get that on the right side by subtracting GCD. Okay. So this cancels. So you're left with FAB minus GFXY. And then on the right, you're just left with negative GCD. Okay, now on the left side, they both have an F, that's good. Now you can factor out an F, so this is going to be FAB minus GXY equals to negative GCD. Okay, there we go. Now we have to get rid of this AB minus GXY by dividing both sides by AB minus GXY. Now do you see our answer? I don't see my answer. On the bottom, can you factor out a common denominator? No. On the top, nothing. Oh, let's see. Oh, this is really difficult one. I can't believe they would put this on the exam. If I had to guess, it would be G. I think it might be A because if you divide GCD by GXY, the G's cancels. So you're left with CD and then you're left with XY. So I think it could be A. Let's see. That's my guess. Correct. Oh my God. Okay. So why I think what they did was they divided each term by so this is all over AB minus GXY. So really what you're doing is you're dividing each term by this. So if you do it here, so it's like saying GCD over GXY. Okay. As you can see, the G's cancel. So you're left with a CD and you're left with an XY in the bottom. So that's why I chose this one. It doesn't have to be you just have to pick the correct one. So this is why I think it's this one. But all the step is correct. Wow, that was a difficult one. Okay. I don't think they'll make I don't know. I don't think they'll have this difficult. They'll probably have one like this that's really difficult. Okay, let's move on. Let's say 17 to anything like 16. So we gotta solve for a small p. Let me write this out. MP plus Q minus T equals to AB. Right? So your goal is to solve for small p. This is a p right here. So let's get rid of this Q and let's get rid of this negative T. Right? So let's add T to both sides and then subtract Q from both sides. This is not a 9, it's a Q. Cancel, cancel. So you're left with MP equals to AB plus T minus Q. And then you solve for small p, solve for P. So you're going to divide this by everything by M, all everything by M. So if you look at our choices, everything is divided by M. So you get P equals AB plus T minus Q all over M. Which is that going to be? Don't be fooled, it's not B because our Q is negative and our T is positive. So our it has to be letter C. AB is positive, T is positive, Q is negative, M is yes. So C. Okay, so this is it for this. So this is an iteration where you have different letters and you go to solve for a certain letter. So as you can see, the first few were difficult, I mean easy, and then 16 was difficult. Yeah, so just go ahead and I know you only have a time limit, so just if you need to review how to do iteration, rewatch this video then. Okay, I am going to stop here.